Let's talk about Leontief input-output models. This technique was developed by Vasily Leontief, a Russian-American economist who won the 1973 Nobel Prize in Economics for his input-output models. Here's the idea. We can analyze an economy by dividing it into sectors and seeing how these sectors interact with each other. Let's look at a very simple model which has just three sectors: manufacturing, agriculture, and utilities. Here's the input, and here's the output. So, for example, in order for the manufacturing sector to produce $1 worth of output, it needs these inputs: 50 cents worth from manufacturing, 20 cents worth from agriculture, and 10 cents worth from utilities. Here's why. Let's say you have a factory. That factory needs inputs from the manufacturing sector itself, like machines. That factory needs input from agricultural sector. Maybe it needs corn or cotton or who knows what. That factory also needs input from the utilities sector. It might need gas or oil or electricity or water or whatever. So this matrix is what we call our consumption matrix. We call it C. An open sector has no outputs, the consumer sector, for example. Suppose an open sector, like the consumer sector, wants the following: D1 of manufactured goods, D2 of agricultural goods, D3 of utilities. Since the product-producing sectors consume some of their own output, we saw that a moment ago here, because in producing manufactured goods, the manufacturing sector uses stuff from manufacturing. Since the product-producing sectors consume some of their own output, their output must cover their own needs plus the outside demand. Suppose that in order to do this, these sectors must produce X1 of manufactured goods, X2 of agricultural goods, and X3 of utilities. So these are their own needs. Okay, you've got manufacturing, agriculture, and utilities. In order to produce X1 of manufactured goods, you need these inputs from manufacturing, agriculture, utilities. To produce X2 of agricultural goods, you need these inputs. And to produce X3 of utilities, you need these inputs from manufacturing, agriculture, and utilities. So we can simplify this by writing it like this. Okay, as a matrix times vector, we're going to call that matrix C. So the total amount produced is X. We need to subtract off CX, the amount produced that's consumed by those sectors themselves, and what we get is the amount that's left over, D. So D is D1, D2, D3. D is the stuff that's left over for, let's say, the consumer sector. So we have X minus CX equals D. Here's how we can factor that. Rewrite X as IX. Now we can factor out the X. So we have I minus C times X equals D. In other words, X equals I minus C inverse times D. I minus C is what we call the Leontief matrix. In order for this to be valid, all entries of X, that is I minus C inverse D, must be non-negative. If all entries of I minus C inverse are non-negative, then all entries of I minus C inverse D equals X will be a non-negative. And we can meet the demand D with sufficient production X. When all entries of I minus C inverse are non-negative, we say the economy is productive. A sector is profitable if the sum of the entries in its column is less than 1. In other words, it takes less than $1 of input to produce $1 of output. If all sectors are profitable, that is, if all column sectors sum to less than 1, then the economy is productive. So, in other words, the entries of I minus C inverse would be all non-negative. So if all sectors are profitable, then the economy is productive.